Okay, so Bismillahirrahmanirrahim. Assalamualaikum and very good afternoon to everyone. Okay, so last topic regarding on so this week we focus on the next topic, which is I thought most of you might be interested in this topic, particularly for those who do the correlational research design. So probably this is one of the analysis that will be included in your report later on. Okay, to answer probably the second or third research objective, which is related to correlation. Okay, so today we are I'm going to introduce you with the next bivariate statistic, which is related to correlation. Okay, so this is the LO. Okay, the LO for decision. At the end of the session, students should be able to identify two types of analysis to determine the association between IB and DB. Okay, to determine the requirement to run Pearson product moment correlation. Okay, so there are two types of association analysis, okay, in which Pearson product moment correlation and Spearman row or Spearman rank order correlation. Okay, the other name of Spearman rank is Spearman row. Okay, and then you are able to run the analysis in Ibm Spss. So probably you may open your your Ibm Spss software with the data that I've shared earlier. Okay, and then lastly, you are able to report the result according to the SIG APA style. Okay. Okay, so this is to refresh everyone. Okay, so we have the main the types of analysis. If we divide according to the number of variable, there are three. The first one is univariate, second one is bivariate, and lastly the multivariate. So univariate involve the analysis that only included one variable in the analysis. So for example, we have the measure of central tendency. Okay, we have the measure of dispersion, and then lastly we have the measure of position, for example. So that one we consider to be the univariate statistic. Okay, the second one is the bivariate, in which the analysis include two variable only. Okay, only two variables. So by the name bi means two. Okay, so the example of analysis that under the bivariate include the Pearson chi-square, Fisher's exact, McNamara test, okay, the Pearson chi-square, mental Hansel, okay, two independent sample t-test, Wilcoxon rank sum, one-way, Kruskal-Wallis, okay, scatter plot, simple linear regression, Pearson correlation, and Spearman row. These are the example lah. Okay. So first, we proceed with the first type of correlation analysis, in which in general, okay, the correlation is used to describe the strength and direction of the linear relationship between two or more variables. So when we mention about the linear, meaning that the two variable is located at one straight line. Linear ni maksudnya is located at a straight line. Okay, and then the correlation, when we mention about correlation, we are interested in two components, which is the strength and direction of correlation. Kekuatan hubungan dan arah hubungan. Okay. Okay, so correlation is designated by R. Okay, this one capital R. Okay, in which the name is correlation coefficient, perkali korelasi. Okay, and then the value of correlation may range from +1 to -1. Okay, the value of correlation may range from +1 to -1. Okay, and then +1 designates a perfect positive correlation. Okay, +1 indicated that the relationship is perfect positive correlation. Meanwhile, the -1 indicates a perfect and negative correlation. Okay. So this is the illustration of the relationship between amount of helping and empathy, for example. Okay. Okay. Before I forgot, another value which is 0. Okay, 0. Because between +1 and -1, there is a 0. Kita balik. Negative, positive. Okay, 0. So 0 here means that there is the absence of relationship. So again, a zero ni indicated the absence of correlation. Okay, zero indicated that there is no correlation between the IV and DV as illustrated in the second figure here, second graph. Okay, as you can see that the relationship, we can somehow cannot determine the direction of the relationship. But for the first diagram, we can predict that the relationship is positive, and then because the flow is onwards. But this one, for the anxiety and emotional stability, it is downwards. Okay, but it is still in straight line. We can draw a line which is straight lah, still lagi. Okay. If let's say I ask you, okay, if the result indicated that there is a negative 0.02, okay, and then the significant equals to 0.01. Is there any relationship or not in this result? Let's say your correlation result give you this output. Okay, just to get your idea. Based on this result, in your opinion, is there any relationship or no? So, ini tukar kepada 1. Example kat sini 0.5. So based on this result, do you think that there is a relationship or not?
Yes.
Yes. Why?
Because the significant value.
This one 5.5, not 0.05, 0.5. Ni 0.5 ni, bukan 0.05. Ada hubungan ke tak? Is there any relationship based on this result? Anybody? Ada. Referring to?
R.
Yes, because when we refer to the R, even though the result, the significant value here indicated that there is no relationship, okay. However, when we refer to the R, there is a relationship. It's just the relationship is not significant. Okay, because the significant value ni indicated either the relationship reach the significant result or not. But this one will indicate is there any relationship exists or not. Okay, as long as you have value here, means that there is a relationship. Okay. Okay, this one. Okay. So the Pearson product moment correlation, okay, this is the brief related to PPMC and Pearson product moment correlation, okay, in which it is resignated by R, general R, correlation coefficient, in which it has been developed by Carl S. Pearson. Okay, and then it is measured by R value, which is correlation coefficient. So this one on your right side, this is the equation for Pearson product moment correlation, in which you have already learned during your statistic class, I'm sure. Okay. Okay, and then, okay, so the purpose, the Pearson product moment correlation is a parametric statistic in which if you want to run this analysis, you need to make sure that both IV and DV in your data set meet the requirement of normality. Okay, so because it is parametric statistics, so therefore you need to make sure that both IV and DV, independent variable and dependent variable of your study, met the assumption of normality. Okay, and then the purpose of running the Pearson product moment correlation analysis is to determine the relationship between the two variables, okay, IV and DV. Okay, then in terms of the requirement, okay, both IV and DV must be in either interval or ratio scale of measurement. Okay, only these two scale of measurement. Okay. You cannot have the categorical scale of measurement to run the Pearson product moment correlation. Okay. Okay, and then the assumption that you must fulfill, okay, to run the Pearson product moment correlation is the first one, the scores for both IV and DB must be normally distributed. Okay, the cases represent a random sample from the population. So there are only two assumptions. Okay. Okay, so this is what we are going to cover in this Pearson product moment analysis. Okay, so there will be two parts. The first one is the descriptive, in which we will try to extract the R value from the output. Okay, and then we try to interpret the direction, either it is positive, negative, or no correlation. And then we try to interpret the strength of correlation based on Guilford's rule of thumb. Okay, and then for the inferential part, okay, we will share with you on how to state the H0 and HA for research that include correlational analysis, report the R value, determine the alpha, make the decision and interpretation, and lastly, present and report your result. Okay. Tak apalah, ni boleh skip ni, laju ni. Okay, so in terms of hypothesis testing, okay, during your statistic class, perhaps the lecturer shared with you the representation of hypothesis writing in according to the statistic, in which this is the symbol that we use. Okay, H0 rho equals to 0, or HA rho not equal to 0, larger than 0 or lesser than 0. But in reality, okay, we can simplify things according to directly mention the name of the variable. So for example, there is no correlation between IV and DB for your null hypothesis. And then for your research hypothesis, there is a significant correlation between IV and DB. Or probably, okay, so this one is based on non-directional hypothesis. Okay, so this one is non-directional hypothesis, the first one is. Okay, because I do not mention the direction of the relationship. But the second one, there is a significant positive correlation between IV and DB. So this one is referring to directional hypothesis. Also again, so how can I determine either it is directional or non-directional? It must be based on the past study. When we do the literature review, we review what is the direction of the relationship based on past study. So therefore, we come up with the conclusion by ourselves. Okay. Okay, this is another one. There is a significant negative correlation between IV and DB. Okay, so to describe the describe the nature of the relationship. Okay, when we want to describe the relationship, the nature of relationship between the two variables in terms of the direction, either it is positive or negative, okay, based on the symbol of positive or negative located in front of the result. Okay, and then we also can determine the strength or magnitude of the relationship by using the Guilford rule of thumb. Okay, so this is the guideline for Guilford rule of thumb, okay, in which there are 5 levels. Okay, so if let's say the value is lesser than 0.2, it indicates that there is a very low relationship or negligible relationship. Okay, if the value located between 0.2 to 0.4, so the relationship considered low. Okay, if the relationship 0.4 and 0.7, it is moderate. 0.7 to 0.9, high relationship, and larger than 0.9, which is 0.9 to 1, indicate very high relationship. Okay, so just to let you know or to remind everyone, the direction, which is the negative or positive, just indicate the direction. Okay, the symbol positive and negative just indicate the direction of the relationship. Either it is negative or positive. But in terms of the existence of the relationship, it is determined by this numerical value. Okay, and then just to remind again, the highest level of relationship is 1. The highest value of correlation is 1. If let's say in your result you have 1 point something, 1.2 or 1.3 and so on. So means that there's something wrong with your data set. Because the maximum value for correlation is only 1. Cannot be more. Okay. Okay, so another computation that we can use, okay, as an alternative to Guilford rule of thumb is Cohen rule of thumb. Okay, in which compared to Guilford, he provided us with 5 level, but for Cohen, he just provide us with only 3 level. Okay, so R 0.1 equals to weak relationship. 0.3 equals to medium, and then larger than 0.5 and above considered high. Okay, this one also you can use lah. Okay, okay, this is okay, so based on the scatter plot, because the direction of relationship as for the result indicated in the analysis, we can use scatter plot to determine the relationship. Okay, so based on the first scatter plot, okay, this is what is the direction of the relationship for the first scatter plot?
Positive.
Positive. There is a positive relationship between X and Y. Okay, so in which the independent variable we locate at the horizontal line, and then the Y we locate at a parallel parallel line. Okay, and then the second one is negative relationship. The last one is there is no relationship. Okay, ini dia punya the illustration lah. Okay, in terms of the strength ni, okay, ni settle lah. Okay, so there are 5 steps of hypothesis testing. Okay, and then the first one. Yes.
Dr. Jap. Okay, back to Guilford rule of thumb tadi kan?
Yes.
Kan macam yang 0.2 to 0.4 tu kan? Dia macam 0.4 dan kat bawah tu 0.4 ni kan?
Yes.
So, either one kita nak choose kalau kita dapat 0.4.
Okay, if let's say it is above 0.4, so it is referring to moderate lah. Okay, so this one is basically 0.2 then 2 less than 0.4. Tapi malas nak buat the symbol ni, so 2.4. So if let's say 0.4 and above, 0.4 to 0.6 something, 0.699 for example, then it is moderate. Okay.
Alright.
Okay, so this one. Okay, so this is the basics, the structured step lah. Okay, the first one, you need to have your hypothesis, both H0 and HA. Okay, we run the analysis and then we are able to extract the test statistic, which is R. Okay, and then we set our alpha. Okay, and then we make decision based on by comparing the test by comparing the significant value and alpha, and then lastly we make conclusion based on the result. Okay, so again, this is the example of hypothesis on null hypothesis and research hypothesis. Okay, this is exactly similar as earlier. And then extract. Okay, so run. Okay, so perhaps are you ready with your data set?
Yes, Doctor.
Okay. So now we try to run the statistical analysis in Ibm Spss. Okay. So to run the analysis, by the way, are you prepared with your data set already? Are you done with preparing your data set? 2 je. Okay, so I give you some time to compute the task mean. Sekejap saya share balik. Dan saya dah compute dah ni. Ilana, just asking. Last 2 sem, Ilana already joined my class, right? Tak
Statistik, Doktor.
Oh ya ke? Okay. Okay. Okay, by the way, you can refer to the first assignment regarding regarding which items referring to task-oriented copying. Please refer to the first assignment, okay, related to which items referring to task-oriented copying, because in this example, I will use the task-oriented copying. Saya nak share ni. Okay, so this is the data set. Okay, so first you need to compute the task-oriented copying. This one. Kena suruh saya buat lagi sekali. Do you have any problem on computing the data? Okay.
Buat lagi sekali lah, Doktor.
Boleh kejap Okay, there is one question from Yong. Okay, Doctor, is it we can choose Cohen or Guilford rule of thumb which support our research? Example, literature set, height relationship, example value 0.5, Cohen mean. Yes, Yong, you can choose either one. Okay, either you want to be based on Guilford or Cohen. It is an optional lah. Okay, you can choose either one. Okay, I will try to rerun tapi saya kena buka dulu ni. I need to open the assignment one because I forgot the number of item. Okay, so by referring to this assignment, okay, so this is the assignment that I'm referred to. Okay, so first we need to compute, make sure that we already compute the philanthropic behavior mean. Okay, and then we you need to compute for all these other IV. So for example, in this case, I want to use task-oriented copying as my independent variable. So the item is item 2, 6, 8, 11, 13, 16 and 19. So saya kena jot down. 2, 6, 8, 11, 12, 16, 19. Okay. So there are 7 items. Okay, so go back to our data set. Okay, so now to compute the data, okay, we click transform and then we click compute variable. Transform, compute variable. Okay, so after the compute variable box appear, then we give the name for our variable. Okay, so for example, I use TOC. TOC indicated for task oriented copying underscore mean. Okay, so this is the name that I prefer to use. Okay, so TOC underscore mean because the name cannot have any space. Okay, so next one I highlight on function group. I go to the function group. Okay, and then click all. Function group and click all. And then go to functions and special variables. Look for mean. Look for mean. This one. Okay, and then double click. Okay, so then it appears in our numeric expression. Okay, so in our numeric expression, now we choose the item. Okay. This one so items 1, 2, 3 ni this one is referring to CP. CP1 until CP21. Okay, so just I mentioned earlier, so the items measuring task oriented copying is the second item CP2. Okay, comma CP6, comma CP8, comma CP11, comma CP13, comma CP16, and lastly CP19. So there are, in overall, there are 7 items. Then CP2, 6, 8, 11, 13, 16 and 19. So in total there are 11 items. Then after that you click OK. Okay. And then again we go to our data set. We can see that there is a new variable appear in our data set. So TOC, task oriented copying. But this one I want to change the location lah. To change the location, I just drag the variable and locate the next to PV main. PV. Okay. This one. Okay. So now to run, are we ready to run the analysis? I hope that you already compute the PV main. PV main dah kan?
Dah, Doktor.
Okay, so now, okay, to run the analysis, we just click analyze, correlate, bivariate. Analyze, correlate, bivariate. Okay. Then after that, after the bivariate correlation appear, you just choose the two variable, which is your IV and DV, and locate under variable box. So this one, PV mean and TOC mean. Okay, and then locate under variable box. Okay. Basically, you can run the correlation for more than two variables, but since this is bivariate, so I just show the correlation by using only two variables. Okay, but in general, you can run more at one shot. Okay, then now click option. So under option, tick for means and standard deviation. Okay, tick for means and standard deviation. But if you already have your mean and standard deviation according to the individual variable after you run the univariate analysis, then actually no need for you to rerun lah, retick, no need for you because it is similar result. Okay, and then click continue. Okay, and then under correlation coefficient box, as you aware, there are three options. Okay, Pearson, Kendall-Staubbe, and Spearman. So this one by default, it ticks on Pearson. So let it be on Pearson. And then now test of significance. The test of significance, the selection either it is two-tailed or one-tailed, it is depend on your research hypothesis. If your research hypothesis indicated that there is a positive relationship, then you need to tick on one-tailed. If you do not mention any direction on your research hypothesis, then you can use two-tailed. Okay, clear? And then now click OK. Now we go to our output. So this is the result for correlation. Okay, this is the first one, which is the mean and standard deviation. Okay, and then the second one is the correlation value. Okay, yeah, semua dapat Okay.
Dapat, Doktor.
Sebab dia senang je correlation ni. Saya pun rasa macam, serba salah sebab rasa macam semua dah pandai ni. Okay, so the next one. Yeah. Okay, so this is the result for our correlation. Okay, so mean and standard deviation are important for interpreting and describing the result. So whenever you report the before you report the correlation result, you need to present the mean and standard deviation for the individual variable first. Okay, so that's why every time we rerun the mean and standard deviation analysis. And then next one, the second table, which is the correlation table, will indicate the the result of correlation between your IV and DV, in which in this case, okay, the R value is
0.341.
okay, yeah. The relationship, the R value between task-oriented copying and philanthropic behavior is 0.341. Okay, so the R equals to 3.41. This is the value. Okay, and then there are two stars here. Okay, so the two star, how we can read the two star here? By referring to the notes located below the table, in which two star referring to correlation is significant at the 0.01 level. Okay, so means that if the result significant at 0.01, so if you set your alpha at 0.5, automatically it also significant. Okay. Okay, and then this is the significant value. Okay, so that's all. These are the only value that we need from the correlation table. Okay. Next one. Okay, then we set our alpha either 0.05 or 0.01. Okay, and then we make the decision by comparing the significant value against our alpha. Okay, we compare the significant value that we have earlier, which is the 0.008 against alpha 0.05. So the criteria is if the significant value lesser or equals to alpha, therefore we reject hash naught. If the significant value larger than alpha, we fail to reject hash naught. So based on our findings, since the significant value 0.008 lesser than alpha 0.05, therefore we reject hash naught. Okay, the results indicated that there is a significant correlation between task-oriented copying with philanthropic behavior. So this is the conclusion for the result. Okay, so in terms of we are done in come up with the conclusion regarding the significance of the result. But based on the value itself, the R value 0.341. So now we need to elaborate further in terms of the direction of the relationship and the strength of the relationship. Okay, so based on the R correlation coefficient 0.341, it indicates that there is a positive relationship between task-oriented copying and philanthropic behavior. Okay, and then by referring to the Guilford rule of thumb, 0.341, it falls within the second range, which is there is a low relationship. Okay.
Doktor,
Ya.
untuk detail analisis ni, kita kena untuk kita masukkan dalam report, kita pun kena mentionkan sama ada the low relationship, bukan the positive relationship or negative relationship tu kita mention jugalah ya.
It is not compulsory, but it is recommended. It is not compulsory, but it is recommended because most of the time when we report the R value, we want to know specifically what is the direction of the relationship. So what is strength of the relationship? So by having to the strength and direction of the relationship, we add more meaning to our findings. Kita masukkan bagi kita boleh we can interpret more based on our finding. Okay, so based on your question, so the question is, if our literature said positive relationship, I choose one tail, but the result, the direction of the result is negative. What should I do? So means that the direction, there's something wrong with either your literature review, meaning that there is a probability that you do not review your literature robustly or thoroughly, or there might be random error in your study, either in when you select your instrument or when you administer the questionnaire. So what you can do? Nothing, but somehow you have to you cannot reject the null hypothesis lah, Yong. Okay. Because the direction is against what is your null hypothesis, what is your research hypothesis. So whatever it is, you have to you fail to reject your null hypothesis. Okay, Yang? But this case happen, this case happen. Okay, so this is how you can present the result for correlation analysis. Okay, table 1, this is how you can write down the name of the table, and then this is the table, how the table should looks like. Okay, the name of the variable, the list of variables should be located under the variable column, and then next to it comes your philanthropic, the DV. Okay, and then you just include the two flowers and then you locate the note below the table, which is the correlation is significant at the 0.01 level by using the two-tail analysis. Okay. So this is the how to report or how to interpret your findings. A Pearson product moment correlation analysis has been conducted to test the relationship between task-oriented copying, which is the mean, equals to 4.43, standard deviation equals to 0.51. So yang ni wajib, this is compulsory to report mean and standard deviation. And philanthropic behavior, mean equals to 3.86 and standard deviation 0.48 among Malaysian volunteers. So result in figure table 1 indicated that there is a significant positive correlation between task-oriented copying and philanthropic behavior. So then you report the result, both R and significant R. Okay, so R equals to 0.341, P equals to 0.008. Or you can also report for the significant value, P lesser than 0.05. This one also acceptable. Instead of you measure the exact result. Okay, so according to the Guilford rule of thumb, the relationship considered low. Okay. Okay. Okay, so I just respond quickly on the Young's question. Okay. So he has the abnormal data. So after she did the transformation, the data are still abnormal. Okay, and then my recommendation is probably you can delete the outlier because you already do the you already do the transformation, but it's still not normal. You are advisable or recommended to to delete the outlier or delete the case. Okay, or else you may want to proceed with non-parametric analysis. This is another option lah, Yong. Okay, but for the outliers ni, I will discuss in the next week lah, in next topic. Because the outliers ni, when it is related to regression. Okay. Okay, Yang. Okay, so any question related to Pearson product moment correlation? So far so good?
Doctor,
Yes.
Doctor, what if for one term punya bagi dua je?
What is it?
Untuk
What
one for one tail punya significant tu kita bahagi dua je
No need. Okay, if let's say for that one is just for comparison analysis that you need to divide by 2 because the analysis didn't provide the one tail analysis. One tail analysis, but for Pearce correlation, okay, the analysis already provide you with either 1 or 2 tails, so no need for you to divide. Okay, so that's why here it indicates that it is 2 tail. If we refer to our output, that is why it is indicated here that our analysis is 2 tail. But if you select 1 tail, then here it will indicate that it is 1 tail. Okay, so correlation tak perlu. Correlation tak sama dengan comparison.
Okay, thank you.
Okay, any other question before we proceed to the second type of correlation analysis? Okay, so next one is Spearman row correlation or Spearman rank order correlation. Okay, so the Spearman row correlation is a rank order correlation. It is by ranking. So when we mention about ranking, it is at least at ordinal scale of measurement. Okay, ordinal. So if you have the nominal data, therefore you cannot use because it is now ranking. Ranking, when we mention ranking, perhaps we expect that we have someone at the first place, second place, and so on. Okay. The purpose is similar to Pearson product moment correlation. We want to determine the relationship between two rank order variables. Okay, so the requirement both of DV and IV must be in ordinal. ordinal scale of measurement. Okay, or okay, if you have the if you have the continuous data, either interval or ratio for DV and IV, you also may want to apply the Spearman rule correlation if your data do not meet the assumption of normality. If your data, if you have the interval or ratio data, but your data do not meet the requirement of normality, you may also consider a rank order correlation analysis or Spearman correlation analysis to look for the association between the variable. Okay, faham Clear Faham Saya risau pula, diam semua. Okay, so what to cover just similar to Pearson product moment correlation. So we are going to talk about the descriptive part in which after we run the analysis in Ibm Spss, we are able to extract the correlation coefficient value. By the way, the correlation coefficient for Spearman rank order we know is designated by RS. Okay. So then based on the correlation coefficient Spearman, we can determine the direction and strength, okay, based on Guilford rule of thumb. For the inferential part, there are 5 steps similar to the Pearson product moment correlation. Okay. Ni boleh laju. Boleh laju. Okay, ni pun boleh laju lah sebab dah tahu dah kan. Okay, sama je. Laju. The other characteristics between Pearson product moment correlation and Spearman rule are similar. It's just Spearman rank order just for ordinal data. Meanwhile, for Pearson product moment is for normal data. Okay, so these are the steps. The hypothesis in terms of hypothesis testing, the way we mention the hypothesis similar. Okay, so now we run the analysis in Pearson in Ibm Spss. Okay, to run the analysis in Ibm Spss, we follow the similar step as in Pearson product moment correlation. We click analyze, correlate and bivariate. Analyze, correlate and bivariate. Okay. Then after lupa pula nak tanya. By the way, have you compute the category data for salary? For example, dah Anybody not yet compute the salary data? Belum lagi?
Yeah, belum.
Tunjuk juga kan ni? Nakal betul lah sendiri. Okay, let's do the computation. We use the education and salary category, okay? Okay, first, because we want to seek for correlation between education and salary, okay? So first, we need to make sure that both variables are in the ordinal scale of measurement. So for education, okay, so we do not need any computation as the data is already in ordinal scale of measurement. How do I know? This one. Okay, based on the data set, as we know that the data already designed 1 until 4 according to the level of academic. So diploma 1, bachelor 2, master 3 and PhD 4. Okay, clear So this one is already in ordinal scale of measurement. But now salary. Okay, so salary, there is no category value here. So means that for salary, the data currently is in ratio. The data is in ratio in which the respondent locate their exact salary. Okay, their own salary. Okay, so now we need to transform this data into categorical. Before we do the computation, we need to determine first the
Range.
Satu the range, but before that, how many groups that we want? Okay, first, how many groups that we want? Is it 5 groups? Is it 4? So it depends on you as researcher. So for example, in this case, I want to have 5 group. Contoh, saya nak, sorry.
Five doktor belum ni five.
5.
Tak nak compute lagi dah buat.
Okay. So for example, we have 5 groups. Okay. So what we need to do first is we need to know the minimum and maximum value for the salary. So if your data you only have around 10 data, then it is okay for you to scroll up and down to check on the minimum and maximum. But since we have quite a number, even only 60, then we need to use, to check the data ni, to check the minimum and maximum ni, we click the data, and we click define variable properties, to know the minimum and maximum. So then after the define variable properties box appear, we just locate the variable salary into the variables to scan. Okay, so under the limit number of values displayed here, make sure that the number located here beyond the number of cases available in your data set. Make sure dia beyond lah. Jangan kalau you punya data set 2000 tapi letak kat sini 2200. So the rest of 1800 wouldn't appear in your scan. Okay. So now then click continue. Okay, then click continue. You all nampak tak box yang appear ni?
Nampak doktor.
Nampak. Okay. So based on this box, it is already arranged to you according to the lowest and the highest. So the lowest now is 1,400. The highest is 11,000. Okay. So now to do the computation, then we get the range first. 11,000 minus 1,400. Berapa? Maximum minus minimum. Divide by number of group. For example, 5. Okay, so we have, nak kena conteng ke? You all dah tahu kan? Kena tunjuk.
Dah tahu doktor.
Dah tahu So 11,000. Okay, formula to determine the level to determine the range or interval is the maximum minus the minimum divide by number of groups. For example, 5. So in this case, we have 11,000. 11,000 minus 1,400 divide by 5. For example, I have, okay, so you calculate lah. So for example, I have set the interval is, the first interval is 1,000 to 299. This is the first one. Second one is 3,000 to 4,099. Next one, 5,000 to 699. Next one, 7,000. Sorry, saya tukar. First one is 1,001. Alamak. 1,001 to 3,000. So first one, second one, 3,001 to 5,000. Next one, 5,001 to 9,000 and 5,000, 7,000, sorry. 7,000. Okay, next one, 7,001 to 9,000. And lastly, 9,001 to 11,000. So this is the grouping that I have set. Okay. Salin Okay, so now to run the computation, we go again to transform. Okay, now we use the function recode into different variable. We use the function recode into different variable. Okay, and then after the recode into different variable box appear, we choose the variable that we want to compute, which is the salary. Okay, and then locate under the numeric variable. Then we change the name of the new variable to salary salary underscore cat. Cat referring to category, salary category. Okay, and then don't forget to click change. Okay, sebab saya dah buat ni. Okay, sebab dah ada dalam data saya. Okay, so next one is you click all and new values. Okay, click all and new values. Okay. For the old and new values, you activate the range function. Activate the range function and you just locate the range according to the set interval just now. The first one is 1001 through 3000, and then under new variable we just write down 1 and then click add. Next one 3001 to 5000. For new value, we use 2. Next one, 5001 until 7000. We use 3. Add. And then 7001 to 9000. We use 4. And lastly, 9001 to 11,000. We use 5. Okay, and then click add and then click continue. Are we done? Are you done? Okay, and then click continue and then click OK. You just click OK. Okay, you just click OK. But for my case, I just close it because I already have in my data set, which is this one. So now we have the new category for salary. Okay, so now then we are ready to run our analysis. Okay, to run the Pearson product, to run the Spearman rank order correlation, so you just click analyze, correlate and bivariate. Analyze, correlate, bivariate. Okay, now reset the earlier data. We just locate our variable, which is education and salary. Just locate the two variable. Okay, now is that meaningful for us to take for mean and standard deviation? Again, is it meaningful to us to check for means and standard deviation? Anybody can answer? Is it meaningful for us to check for mean and standard deviation?
No.
No. Okay, it is meaningless for us now because the data is in categorical form, which is the ordinal. So it is meaningless. Tak ada makna kalau kita report mean ni. Maksudnya mean tak ada apa-apa. Okay? So no need for us to take for means and standard deviation when you run the Spearman because it is meaningless. Okay? And then make sure now under the correlation coefficient we take for Spearman. Okay, we take for Spearman. And then the test of significance, it depends on your research hypothesis, and then just click OK. Okay, and then we check our data. We check our output. Okay, so this is the finding for our output. Okay, the table is just similar as in Pearson product moment correlation, just similar. Okay, so the one that we need to report, okay, so then we go to our slide. Okay, I will answer later, Young. Okay, then after we run the analysis, okay, so this is the result for Spearman rank order correlation. Okay, the first that what we need to report is the significant value, which is if the significant value lesser or equals to alpha, we reject hash naught. If the significant value larger than alpha, we fail to reject hash naught. Okay, so in this case, since significant value is 0.000, which is lesser than alpha, so it indicates that the result is significant. Okay, so meanwhile for the Spearman rank order correlation coefficient, panjang. Okay, 0.710 indicates there is a positive because there is no symbol in front of the value and height relationship between level of education and salary. Okay, the higher your education, the salary is expected to increase. Okay, so you determine your own alpha, either 0.05 or 0.01. Okay, and then you make the decision. So this is the decision. Since the significant RS, I forgot RS. Since the significant RS 0.000 lesser than alpha 0.05, therefore we reject the hash knot. Means that there is a significant correlation between level of education and salary. Okay, then we elaborate further by describing the nature of the relationship based on the Spearman rank order correlation coefficient value, which is RS equals to 0.710, indicate that there is a positive relationship. And then by referring to the Guilford rule of thumb, okay, 0.710 is falls within the fourth range, okay, which is the height relationship exists between level of education and salary. Okay. Next one. Okay, so this is how to report the Spearman rank order correlation in table. Okay. Just similar to Pearson product moment correlation. So then this is how to report the Spearman rank order correlation. A Spearman rank order correlation analysis has been conducted to test the relationship between level of education and salary received among Malaysian volunteers. Results indicate that there is a significant positive correlation between level of education and salary. R equals to 0.710, P equals to 0.000. According to the Guilford rule of thumb, the relationship considered to be high. Okay. Okay, so related to Young's question, if we report for demographic profile, that categorical data, so do we report the mean and standard deviation? Okay, it is depend on the availability of your data. For example, if you have collected the if let's say in your questionnaire, for example for salary, so you already determine the groups in your questionnaire, meaning that you collect the data in grouping form, so therefore it is impossible for you to have the mean and standard deviation. So means that no need for you to report. But if you collect the data in ratio form, okay, then after you compute into the categorical form, then it is possible for you to get the mean, then therefore you can report the mean lah. Okay, it depends. If let's say from the very beginning you collected the categorical data, then it is impossible for you to come up with the mean and standard deviation. But if in your questionnaire the raw data is in interval or ratio, yes, you need to convert first in the group in grouping form, and then later on you calculate the mean and standard deviation based on the raw data. Okay? Yeah.
Okay, thank you, Doctor. If how about like gender, like education level, that one?
Yeah. Is it possible to get the mean for?
All right.
Is it possible?
But when we run the SPSS, the mean and SD they will calculate it, but I feel that it's like impossible. So that's why I like wondering.
Okay. SPSS is just a system. Okay. Just a system. Whenever any numbers that you insert into IBM SPSS, they will give you the value. But either it is meaningful or not, it depends on the researcher to interpret it. Therefore, as a researcher, we need to be very selective in reporting our data. We need to make sure that something that we report is actually meaningful. Because SPSS is just the system, it cannot control. But the one that should have the knowledge on which value to be reported is the researcher. So that's why you attend this class. So you know that which value need to be reported and then which value shouldn't be reported. Okay? Yeah. So for example, gender. When you come up with the mean, then the result is 1.5. So what is 1.5 Yong? So because as far as I know, because everybody know only only two gender, right?
Yeah.
So similar.
Okay, understood, Doctor.
So similar for race as well. So for example, you have included Chinese, Malay and Indian, for example, 1, 2, 3. So then after you add, there is 6, right? 3 plus 2, betul kan? 6 kan? 3 plus 2 plus 1, 6. So then after, let's say for example, you divide by 3, then you have 2. Right, so 2 is it considered what is 2? Is it Indian? Right, this meaningless. Okay. Okay, so is there any other question? I thought we stop here lah. Tak lah ini, tak boleh laju sangat dah. Kita dah lecture note ni dah week 11 dah. Is there any other question? Sejam je kelas. Ke nak continue?
Doktor?
Yes.
Doctor, regarding assignment number 2, we need to refer to another assignment number 4, 5, 6. But you still not.
Means that it's okay. Means that complete the next assignment first, then only then you go back to the second assignment.
Okay, Doctor. Thank you very much.
Okay. Okay, ada lagi soalan? Kena masuk the next topic so that we can have kita boleh rehat awal nanti. Tak nak. Tak nak, Doktor. Tak nak ke? Tak apalah. Okay, so next week I hope that most of you can attend, because I'm sure that next week going to be one of the topic that you wait for, which is on regression. Okay, because I'm sure that most of you will use the regression lah. Okay, sebab yang ada siapa-siapa yang buat PhD ke ataupun Master Science ke kat sini? Tak ada kan? Is there anybody who do the Master Science or PhD here? So probably you may interested to do the, okay. So probably for where wrong, you are interested for the mediation and moderation analysis lah. Itu untuk nanti lambat sikit. Okay, so if there is no more questions, so we stop here. Again, I would like to wish selamat Hari Raya, maaf zahir dan batin kepada semua. Okay, so take care everyone. Sebab saya pun ada dengar juga ada few new cases on COVID ni. So please take care. Okay, among student ke among saya punya jiran pun dah ada. Okay, so take care guys. Assalamualaikum.
You too, Doktor.
Selamat Raya.
Terima kasih, Doktor.